Ever had your computer freeze up? It's like a kid at an arcade who ran out of quarters, but keeps slamming the buttons anyway. The machine gets overwhelmed by all those invalid requests, and the whole thing locks up. There is a different kind of player designed to fix this. It's called the CohAtom. The CohAtom is physically incapable of making a move that breaks the rules of the game. This is the blueprint for a CohAtom. In the center, you can see a permanent rule set, the glowing sphere that anchors everything. Surrounding it are bands of allowed action, like glowing rings, defining exactly how far the atom can move. Because the atom follows these strict layers, it survives the chaos that crashes normal computers. The architecture ensures that no action can happen without a verification check that is as solid as a mathematical proof. Instead of using standard computer bits, those simple ones and zeros, this system uses something called a CohBit. Think of a CohBit as a highly specific permission slip. It describes exactly what move the atom wants to make and precisely how many tokens it will cost. Before the atom can use that slip, it has to get past the verifier. You can imagine the verifier as the world's strictest arcade bouncer. This bouncer checks every single permission slip against the atom's available tokens and the rules of the game. If the bouncer approves the slip, the move happens. If they reject it, the system doesn't break or glitch. It simply holds its position, staying perfectly stable until a valid move is proposed. The bouncer uses a scale to decide. They weigh the atom's tokens against two things: the cost of the ticket plus the weight of any actual friction the move creates. To get through, the tokens must outweigh both the price and the mess. This pre-execution check is what removes the possibility of a crash. Problems are identified and stopped at the entrance, so the internal engine never encounters a situation it can't handle. For a computer to finish a complex task, it has to link thousands of these permission slips together. The system follows a rulebook for these combinations called CohBit Algebra. The first rule in the book is the identity move. Mathematically, this is the act of doing nothing at all. Doing nothing is a vital safety feature. If the atom runs out of tokens, it defaults to this identity move. Since doing nothing costs zero budget, the atom stays alive and stable, waiting safely for a fresh injection of tokens rather than dying. When the system needs to play two different games back-to-back, it uses sequential algebra. The verifier pre-calculates the total cost of both games before the first move even begins. It adds up the entire sequence and locks in the total token requirement at the very start. This prevents the system from getting stranded halfway through a job. It will only start the first move if it has already proven it has the tokens to finish the last one. Sometimes a computer needs to handle unrelated tasks at the same time. For this, the rulebook uses parallel algebra. The math here is simple addition. The system sums the costs of both tasks to make sure the atom can afford to execute them simultaneously. Then there is mixture algebra. This is what the system uses when it has several valid choices and needs to find the most efficient path forward using probability. Picture this like a spinning wheel. The atom spins through all potential games, looking for the highest reward. But the verifier stands over the wheel. Before it spins, it removes choices that are too expensive or unstable. Only moves proven safe and affordable are left to be chosen. This creates a controlled way to explore. Probability lets the system search for the best move, while the verifier ensures that whatever move is picked is legally allowed. This algebra scales up. When thousands of these atoms work together, the system combines their individual budgets and rules into a single shared map. Because every path is pre-verified as a single coordinated unit, thousands of atoms can flow together without ever running into each other or causing a collision. This is the macro architecture in practice. The donut-shaped chamber in the middle is where these rules are applied to the atoms as they flow through. The outer ring acts as a final safety boundary, ensuring nothing exits unless it follows the math. This stands in contrast to how standard generative AI works. An AI hallucinates, making up fake information, because it predicts the next step without a bouncer checking its logic or its budget. It is making guesses without a safety rail. The Coh framework requires every action to be mathematically proven and fully paid for before the machine even blinks. We are entering a time where computing is about more than just speed. It is about taking complex, massive ideas
and executing them with absolute mathematical certainty.